Hey guys, so there have been a couple questions over some of the exponential functions, and so I thought I would just do a little follow-up lesson on these. So, specifically about how to evaluate exponential functions. So, what we're going to do is I'm going to do 15, 19, and 29, and this is in your homework from the other day. It was page 457, 9 through 33 odd. I believe that's it. Yeah, 457, 9 through 33 odd. So this is before we got into the specifics of exponential growth and exponential decay. This is just exponential functions as a whole. So, exponential functions as a whole aren't too bad. All we're really, especially on 15 here, what we're doing is we are taking our value for t, which we're told is t is equal to negative 2, and we're going to plug it in for our exponent here. You see how it's 0.4 t. So I'm going to rewrite this. It's gt is equal to 2 times 0.4 to the t power. Now, if you wanted to, you could change this 0.4 to a fraction, right? So 0.4 is equal to 2 over 5. So I'm going to go ahead and plug that in. So it's going to be 2 times 2 over 5. Wow. I'm going to just erase that whole number. That was terrible handwriting. 2 over 5 times t, or to the t power. Now we are told that t is equal to negative 2. So what do I do with that? I'm going to plug it in for my t value up here, or the t variable. So then I have 2 times 2 over 5 to the negative second power. Now the first thing that we should do whenever we are taking something to a negative power is I'm just going to go ahead and start off by flipping everything that's in the parentheses here. So I'm going to get rid of the negative by flipping that fraction. And what we got is 2 times 5 over 2 squared. Now, I'm going to distribute the squared to each of these. It's going to become 2 times 5 squared over 2 squared. Then that's going to become 2 times 25 over 4. Now we can multiply this out, but really, since this is the same as saying 2 over 1 times 25 over 4. So we could multiply straight across and then simplify our result, right? But another way that I like to do it, at least, is see if you can do cross simplifying here first, because then you don't even have to simplify it at the end. So if you can cross simplify in a multiplication, like a fraction multiplication problem, later on in the problem, you won't actually have to simplify your end result. It'll be as simple as it can get. So then this is going to be 1 over 1, because we can divide 2 and 4 by 2, right? So 1 over 1 times 25 over 2, which equals just 25 over 2. And then if you want to get technical, make it into a mixed number. And our final answer is going to be 12 and 1/2. So this is all to number 15. Okay, now let's look at 19. We could do the same thing for number 17 too. Actually, I'll just show it to you anyways. So 17 here 17, we are going to have negative 0.5 times 4 to the w power. Now, I'm not going to ask you guys to do 4 to the 18th power. So what I'm going to do here is we are going to plug 18 into here. So this is going to be negative 0.5 times 4 to the 18th power. And then let's just simplify this. So negative 0.5 is the same as saying negative 1/2 times 4 to the 18th power. So what we're going to do there is just multiply this out, and our final answer that I would expect you to have on the test is just going to be 4 to the 18th power over 2, and then make it a negative. So negative 4 to the 18th power divided by 2. Alright? Alright. Let's do 19. So a population of 75 foxes in a wildlife preserve quadruples in size every 15 years. The function, so I'm going to write that down here, y equals 75 times 4x, where x is the number of 15-year periods, models the growth. How many foxes will there be in 45 years? So the thing you got to recognize here is that this 45 is not what we're going to plug in for x. X does not equal 45. Because we're told that x is the number of 15-year periods. So what we want to do is x is equal to 45, because it's how many total years we're looking for, divided by 15. And that's going to give us 3. So then we're going to plug 3 in for x. And you're going to get y is equal to 75 times 4 to the 3rd power. Alright? And we're just going to go ahead and multiply this out. 4 to the 3rd power is equal to 64. Because 4 times 4 times 4, so 4 times 16 is 64. So then you're at 75 times 64. Which you could use you guys all have calculators, you could use a calculator for that. I will do the math here though, so you got 75 times 64, you're going to have 0, carry the 2, 28, 30, then you're going to have 0, 0, carry the 3, 42, 45, add everything together, you got 0, 0, 8. So that means that in 45 years, why did I say foxes? No, okay, yeah, I'm looking at 28 here. I got super confused there for a second. I forgot what problem. Alright, so ignore that. Yeah, after 45 years, there would be 4,800 foxes. Alright. Okay. So that is 19. Now let's look at 29, because I know this is one of your guys' problems. And I know these word problems can be kind of tricky, but it's all about reading and figuring out what are we really looking for here. So 29. A solid waste disposal plan proposes to reduce the amount of garbage each person throws out by 2% each year. This year, each person threw out an average of 1,500 pounds of garbage. So when we're reducing it by 2% each year, that means that each year it's going to be 98% of our last year, right? So if I'm reducing it by 2%, that means that what I had this year, let's say it was 100, what I have this year is going to be 98 next year, right? So what you want to do is find out what 98% of the previous year's waste is going to be. So this year, each person threw out an average of 100 or 1,500 pounds of garbage. The function y equals 1,500 times 0.98x models the average amount of garbage each person will throw out each year after x years. Graph the function. So what we want to do here is, this is going to be a fun one. So I'm not going to, on your guys' test and stuff, I'm not going to have anything this crazy here, but it wants us to graph it out. So I'm going to put an x and a y here. The idea here, and I'm just going to do a very quick graphing. I mean, it won't be necessarily super accurate, but what we're doing is, if x were to equal 0, then that would mean that we would have 1,500 times 1, right? So if x equals 0, then our y value is going to equal 1,500. So at our very top here, we're going to have 1,000. Well, I guess we'll do it here. 1,500. Now, if x equals 1, then we would have 1,500 times 0.98, which is going to be 1,470. Now, let's say we had x is 10. Anyways, though, your graph is going to start here, and it's going to go down. See how the slope is very steep to begin with? And then as the longer it goes, the more it's going to level out. Our graph is going to look something along these lines. It's not going to be perfect like this, and I will never ask you to graph anything out like this large or anything. It'll be a fairly simple one. But this is how you would actually graph it out. So you would plug in various values for x, and then you would find out what your y value is, and just plug that in, and then it's like connect the dots. And since this is decreasing each year, you see how this is 0.98, which is the same as saying like it would be a fraction to a power. So since it's a fraction or a decimal, so it's less than 1 to a power, we know that our graph is going to be going downwards and then evening out in the long run. It's going to get closer and closer to 0 without actually being 0. This is an example of an exponential decay, which is what we talked about in class on Friday. But I'm going to put another video up here shortly explaining it a little bit further in detail. So don't worry so much about graphing this one out completely. Any exam you have, it's not going to have you graph out something as crazy as this, at least not any exam that I'm writing. So I can't promise anything on the final, but you could at least have a general idea of how to solve these kind of things just by plugging x into the exponent, where it has the 0.98x. Well, I hope this helped answer a couple of your guys' questions, regarding exponential functions. Again, guys, please reach out to me anytime you have a question. I'm more than happy to help you guys out in understanding this, especially because I know the last week was kind of a little bit rushed because I wanted to get as much in as possible before I left. So anyways, though, if this helped, feel free to if this helped you out, feel free to reach out to me anytime you need some help in other topics, and I'll continue to make videos like this for the rest of the year probably. Alright guys, have a good weekend, and good luck with your test this week.